All right, so now we're doing a changing cube, and I'm actually going to do this question twice. The first time I'm going to actually answer the book question. The second time I'm actually going to do what we did during our lunch study session. So a changing cube, the volume of a cube is increasing at a rate. So I know increasing at a rate means this is a related rates problem. So let's start with given, constant, instant, question, and then I'll put my formula over here. All right, so we got a cube. The volume is getting bigger, therefore the cube itself must be getting bigger. Try to make this cube slightly more accurate than the one I did in class. There we go. All right, so a cube means all the sides are the same, and instead of using s, I'm going to use x. All right, so the volume is increasing at a rate of 1200 centimeters cubed per minute at the instant that the edges are 20 centimeters. There's no constants in this problem because while the volume gets bigger, the cube side gets bigger. And the question is, what rate are the edges changing at that instant? So the formula would be volume is equal to x times x times x. So that's x cubed. dv dt is equal to 3x squared dx dt. And dv dt was 1200 equals 3 times x, which was 20, squared dx dt. And so we get that dx dt is equal to 1 centimeter per minute. All right, so we are looking at the exact same problem, but I actually changed the question now. So now I changed it, so I want to know how the surface area is changing. So I'm actually going to steal the information we had before. We knew that the given was that the dv dt was positive 1200 centimeters cubed per minute. We knew that there were no constants. We still want at the instant that the edges are 20 centimeters. We know then that the question is now ds dt. So my formula that I want to use is surface area, which is 6, and we're going to use x squared. So there's 6 sides, they're all the same, and the area of the sides are x squared. So ds dt is equal to 12x dx dt. Now, let's look at what I have, and you'll notice I need to know x, which we have, but I need to know dx dt, which we don't have. So this is one of those questions. It's actually pretty easy. You should realize we never use the given information. So I'm literally going to take a break from my work, and I'm going to look at the given information. I get volume. The volume formula would be x cubed. And so dv dt is equal to 3x squared dx dt, and this should look familiar. We just did this same exact problem, and if you remember, we got that dx dt was 1. You actually had to do that to solve this problem. So now we get to go back from our break into the problem we were solving, and the surface area is changing by x times 20 times 1, which would be 240 centimeters squared per minute. So if the information that they give you and what you want to find don't seem to match up, meaning the other type of question I could ask is, given the rate at which the area of a circle is changing, I could ask you how fast is the perimeter or the circumference of the circle changing. That would be very similar to this question. They're both related by the radius. In this question, they were both related by x, which was the side. So you might have to take a break from the question if what they gave you, the v, is not related to what they're asking you, s. They're not directly related, but what you'll notice is the formulas for each of them both have the same variable. That's how you're able to do this question.